Hello guys, today we'll look into the most basic but most important metric in machine learning and data science, that is accuracy, precision, recall and F1 score. Before we look into this concept, I will share a common use case related to binary classification, and then I will explain the idea behind the confusion matrix, which is the foundation for all these metrics. Now I have opened up my whiteboard where I have filled many items beforehand to save some time. Imagine we have two types of vehicle, car and van. Each vehicle has certain and common features like weight, speed limit, body shape, engine, and so on. We have already plotted these features. Then we will try to draw a line that separates these two groups. In our case, we have two groups. One is car, one is van, and they are represented by X and 0 in the graph. We have already plotted this feature on the graph, and then we will try to draw a line that separates these two groups, that is car and van. But as you see, not everything is perfectly split. That means some point will end up on the wrong side of the line, leading to misclassification. In our case, we have one dot over here and two dots from here. It may be some cars might look a lot like van based on the feature we choose and vice versa. This is totally normal in real world problem depending on where we draw the line, our threshold. And some prediction will correct and some will not. This is where the concept like confusion matrix, accuracy, precision, recall and F1 score comes in. They help us to measure how well our model is doing and understand the type of mistake it makes. By the end of this video, you will know how this foundational idea connect and why they are so important for anyone working in machine learning or data science. We'll look into our next topic, that is accuracy, and we'll see how our confusion matrix help us over here. But here is the thing, in our real world most of the data is unbalanced. For example, if we consider one random data which has like 95% negative class data then positive one or vice versa, then in that case accuracy alone can be misleading. In another word, for heavily imbalanced data set where one class appear very rarely, say 2 to 3%, then the model would predict negative class 100% of the time because model has overlooked the another class and the accuracy is 100 or 99%, but the model will be useless. Mathematical path, like to calculate accuracy, we have to sum up the correct classifications that are true positive plus true negative divided by sum of all the outcomes of confusion matrix. True positive, true negative, false positive, false negative. So accuracy tells us how many predictions our model got right, both for the positive and negative class. A perfect model would have no mistakes at all. If I go back to the confusion matrix over here, false positive will be 0 and false negative will also be 0. So the accuracy would be 100%. Accuracy can give us a good overall sense of how well our model works. That's why it's often the default metric people look at. Moving to next topic, that is our precision. Precision measure how many of the item our model predicted as positive actually are positive. And to calculate it, take true positive divided by sum of true positive plus false positive. Now to achieve a higher precision, what we can do, we have to make sure that our false positive is really low. If our false positive is low, then our precision is high. High precision means that there are few false alarms, so most positive results are correct. Precision gets better as the number of false positive goes down. If a model makes a 0 false positive mistake, then the perfect score of precision will be 1.0. After completing precision, now we'll look into recall. Recall is also known as true positive rate. which tell us how good our model is at finding all the real positive. If we have a question, out of all the positive cases, how many did the model catches? So recall can answer that question by measuring the portion of actual positive that the model correctly identified. For example, in COVID detection, recall is the percentage of all persons that were correctly labeled as COVID positive. A perfect model to say about recall will be like 1.0, and which means it catches every positive cases and did not miss any. Recall become especially important when missing a positive case is a big problem. Suppose we have a COVID positive person and our system does not detect it, then it's a big problem. Similarly, in other use cases like fraud detection, spam detection, and other cases where we have to make sure like we detect all our positive cases, or else we'll face serious consequences, then recall is must to calculate. If the dataset is imbalanced and positive datasets are really rare, recall is much better idea for the model performance than accuracy alone. So the mathematical formula for recall is true positive by true positive plus false negative, and we have to make sure that the false negative is really low or close to zero so that we get a perfect model and our recall has a value of 1.0. Now we'll look into F1 score. F1 score is a harmonic mean of precision and recall, which means it only gets high if both precision and recalls are high. It is especially useful when you want balance between recall and precision on imbalanced dataset, catching as much as positive set of data and avoiding false alarm. Now you see the relationship between precision, recall, and F1 score. So accuracy, when we say like, then it means the percentage of all prediction the model got right, correct. Overall, the proportion of correct prediction, that is true positive plus true negative. So it is considering both factor. While in precision, out of everything the model marked as positive, how many were truly positive? So for example, model has predicted in A case, B case, C case, D case. I just randomly take it. This is positive, this is positive, this is positive. And the ground truth is this one is positive, this one is also positive, but this is not positive, and this one negative. Now we have one factor that we see where the model says it's true, but in reality it's not. So that means we have one precision is linked with false positive. And to improve precision, we have to make sure like the false positive is less so that precision can increase. If precision will increase, false alarm will also reduce. What is false alarm? A false alarm is when model or test say something is positive but it's actually negative. Why is important false alarm? Because suppose if test report says that someone has COVID but they actually don't, so it's a false alarm. Recall out of all the actual positive, how many the model correctly found positive? Out of all the actual positive. So example, in our ground truth, all are positive. For example, A, B, C, D. This one is true, this one is not, this one is not, this one is. So over here, model failed to predict the 2 1, right? So our false negative will be 2. Recall is linked with false. Now recall is linked with false negative, right? False negative. To improve recall, what we have to do now? Where we have to focus? We have to focus false negative should decrease so that recall can increase. Correct. So over here we have, if we have high recall, that means we will miss few positive. Precision improves as false positive decreases while recall improves when false negative decreases. As a result, precision and recall often show an inverse relationship where improving one of them can worse the other. So, improve precision, then we have to keep an eye on recall so that it should not get worse. So, it is inversely proportional somewhere. Correct. Now, coming to our last part, F1 score. F1 score is the harmonic mean of precision and recall. It is helpful when we want our model to find as many as positive. We want our model to find as many as positive, that is high recall, while avoiding too many false alarm, that is also precision. So the difference between accuracy and F1 score is accuracy is the percentage of all correct prediction, whereas F1 score is the balance between precision and recall. Lastly, I would like to recommend Google machine learning course for classification threshold. Over here, when we change the threshold value, then our confusion matrix gets updated. Based on our confusion matrix, like accuracy, precision and recall values gets updated. So I will highly recommend, go check it out and keep learning. That's all for today. Thank you.